Hello, we are going to learn together the equation of a line. Wow, sounds scaring, but you'll see that actually it's not that scaring. So, if you go to a class and you see many children, your friends, every child has a name. So, when I look at the child, I should be able to call the child. So, every child has a name. I should know that here we have Christy, and here we have Alfie, for example. Yeah, I look at the child and I can say its name. Opposite, if I say the name of a child, so I'm thinking, for example, as Andrew, I am able to draw Andrew. Okay, as you see, I'm not very good at drawing. Okay, so I look at the child, I should be able to know the name. I look at the name, I should be able to draw the child. Same, each line has a name. So when I look at the line, I should be able to name it. And when I see the name, I should be able to draw the line. In a coordinate system, which we see here, we have two axes. The x-axis is always a horizontal one, and the y-axis is always a vertical one. Our lines will lie on that coordinate system. And I can have many lines here, like for example that line, or that line, or that line, or that line. There are infinitely many lines. Now, how can I make a difference between them? Right? I should be able to give them a name, and I give them the name following their properties. We are going to start looking first only at horizontal and vertical lines. Suppose I am looking closer to that line. Now on that line there are many points. Let's take this point here. The point here has a coordinates 2, 1. X coordinate is 2. So if you start from 0, to get to this point you need to go 2 units to the right in the opposite direction and 1 unit up. So the coordinates are 2, 1. The point here has a coordinates 3, has a coordinates 2, 3. 1, 2, 3. Okay, has a coordinates 2, 3. So to get to this point I go 2 units to the right and 3 units up. The next point has a coordinates 2, 4. The point above is 2, 5. The point here is 2, negative 3. Yeah, so to reach this point you go 2 units to the right and then 3 units down. Look at all these points. All these points follow the property that their x-coordinate, the first coordinate, is 2. The first coordinate is called the x-coordinate. So all the points have x equals 2, and this is the name of this line, x equals 2. Now I can draw, for example, the line x equals negative 4. So on that line there are going to be all the points with the x-coordinate negative 4. For example, negative 4, 0, negative 4, 1, negative 4, 7, and so on. So negative 4, 0. We start from 0, go 4 to the left, and 0 horizontal vertically. So this is your point negative 4, 0. The next point, negative 4, 1. So you start from 0, you go 4 in the negative direction and 1 up. So this one is negative 4, 1. The first one was negative 4, 0. This one is negative 4, 3. All the points having their x-coordinate negative 4 are going to be on that line. Imagine it's a line. So this line has an equation or the name x equals negative 4. These are vertical lines. Let us now look into horizontal lines. Consider this line, horizontal, parallel to the ground, parallel to the x-axis. And let's take some points on this line. This point, for example, has a coordinates 1, 3. So if you start from 0 to get to that point, you go 1 horizontally and 3 vertical. Another point, this point, has a coordinates 3, 3. This point has a coordinates 7, 3. This point on the same line has a coordinates -6, 3. And you can continue. Look at all these points. Their second number is 3. The second number is always y. So this line has a name, y equals 3. Yeah? Every point has two coordinates. First is called y and the x, and second is called y. So for all these points, y equals 3. Let's take another line. For this line, if you take some points, you will see that for all the points, y equals -4. So this is the equation of this line. Let us try to draw some horizontal and vertical lines. Let's suppose we have the line y equals 7. So all the points with their y coordinate 7. So if it's a y coordinate, then of course I look on the y-axis. My y-axis is the vertical one here. So y equals 7. 1, 2, 3, 4, 5, 6, 7. All the points with their second coordinate 7 are here. Consider the line x equals -3. X is a first coordinate, so the first number must be -3. I go on the x-axis, -1, -2, -3. All the points having their x coordinate equals -3 are here. Y equals -5. So y is a vertical axis, y was -5, 1, 2, 3, 4, 5. So this is the equation of this line. Y was -5. X equals 6. I go on the x-axis, 6, 1, 2, 3, 4, 5, 6. And this is the line. With the name x equals 6 because all points on this line have their first number, their x coordinate equals 6. We are going to learn now how to draw other types of lines. So it's like I know your name and I can draw your face. Now I know the equation of a line, the name of a line, and I want to see where my line is positioned on the Cartesian system, the coordinate system. So let me take an example. Y equals 2x plus 1. In order to draw a line, suppose on this surface here, I'm telling you, I'm thinking of a line. What line I'm thinking of? Can you guess? You can put this one. Is it that my line? No. That one? Is that my line? No. So we can keep guessing. And because there are many lines, you cannot point my line. What do I need to give you? If I tell you my line passes through this point, do you know my line? Is it that one? No. Can be that one, maybe. This one or this one. There are many lines passing through this point. So in order to know my line, I need to give you 2 points. If you know these 2 points, then this must be my line. There is no other line passing through this point. If I want to draw the line called y equals 2x plus 1, I need 2 points. And between the 2 points, it should be that pattern. So I can take an x I want. For example, x equals 0. Then y will be 2x, x is 0, 2 times 0 plus 1. So y must be 1. So here we have the point of coordinates 0, 1. X equals 0, y equals 1. Here is my point. That's a point on my line. Let us find another point. We have the same equation. That's the name of the line. Suppose x equals 1. Then y is 2x plus 1. So y equals 3. So your point is 1, 3. So x equals 1, y equals 3. And here is your second point. Now, you'll know, of course, that this is the line I'm thinking of. This is a line called y equals 2x plus 1. Very often, it's enough, of course, to have 2 points. But very often, actually, we generate more than 2 points. We generate 3 points so that we can check if they are all on a line and I don't have any mistakes. So I would continue, for example, with taking x equals 2. And then y equals 2x plus 1. Remember, 2x. If it's no operation between them, then it's times who has been omitted, multiplication. So y equals 5. So we have the point of coordinates 2, 5. When x is 2, y equals 5. 1, 2, 3, 4, 5. So see, it's on that line. So that's the equation y equals 2x plus 1. Shall we try another one? Let's take y equals 3x minus 2. So in order to draw this line, you need 2 points. So we can start with any x I want. X equals 0, for example. And then y is 3 times 0 minus 2. 3 times 0 is 0. 0 take away 2 is minus 2. So my point has the coordinates 0, negative 2. X equals 0, y equals negative 2. So this is my point. Let us find another point. X equals 1, for example. Then y is 3. 3x, so 3 times 1 minus 2. So y equals 1. So we have the point of coordinates 1, 1. X equals 1, y equals 1. So this is a point of coordinates 1, 1. Now we could stop and draw the line, but I will continue so that I'm sure that I have these 2 points correct. The third should be on the same line with these 2. So let's take x equals 2. And then y equals 3 times 2 minus 2. Y equals 6 minus 2, 4. So I have the points of coordinates 2, 4. X equals 2, y equals 4. See how they lie on a line. And this is a line. Y equals 3x minus 2. Now we are going to start and draw your own lines.